Okay, good morning. Today we discuss about osmotic pressure. What is osmotic pressure that we discuss, and second topic that I want to discuss, that is quantum factor. Theoretical and practical molecular mass is different. So scientists want to discover which type or which process is going on practically. So we are not getting the proper molecular mass. So that is quantum factor. Okay, I symbolic. That we'll discuss. What is the difference between practical molecular mass and real molecular mass? Okay, real and practical will be different. That we'll discuss. Before that, again I revise the osmotic pressure. Osmosis. Okay, what is osmosis? It is a biological process, osmosis, in which solvent migrate from higher concentration to lower concentration or lower concentration to higher concentration. Suppose we take the two solutions. Okay, solution 1 and solution 2. Here concentration is 5 mole. Its molarity is 5. And here molarity is 50 mole. This solution is prepared by adding NaCl plus water. So we have prepared this solution by adding NaCl in water. So water is a solvent and NaCl is a solute. Here 5 molarity means in 1 liter solution I have added 5 moles of NaCl. Here 50 moles of NaCl. So concentration of this is this. Here in between these two containers there is semi-permeable membrane. Semi-permeable membrane means only solvent molecules can pass through. Means water molecules can pass through container A to 2 or A to B or 1 to 2 or 2 to 1. It can move here and there. Okay, further, vice versa. But only solvent molecules. Why? Because particle size in that is very less, in nanometer. Its size is what? Nanometer. It has a filter just like filter paper. Its size will be of, number is given to it, 255. Just like sandpaper number is there. 180, 150. So similarly, this mesh size particle is there. Now, what really process take place, that we discussed by filling this with the solution. You fill the solution. Okay, this is 50 molar and this is this. Now evaporation starts. Water will evaporate and collect over here. Again it tries to pressurize the liquid. Condensation. Okay. Condensation no, but it try to get. First, if you fill this solution with 50 ml up to 100 ml, okay, then it starts to vaporize at particular temperature, lower than boiling point, but it starts to vaporize. First, 1 drop will come, okay, water. Second drop, third drop. Then what? Vapor pressure increases. Then it tries to create pressure on this water. That's why surface of the water is like this. Understand? That is vapor pressure. This pressure you can measure with the help of pressure meter. एक pressure meter लगा दीजिए तो अपने आप इसका pressure पता चलेगा. Similarly, here also this thing happens. So here also you apply, okay, join the pressure meter. So here what? Pressure is applied on the water. Now instead of 5, I take suppose 1 molar is there, very less. Then these water molecules will come up in the gaseous form very fast. Why? Because no NaCl is there. So here pressure is high and here pressure is low. So water molecule, because of this pressure, water molecule starts to migrate from lower concentration to higher concentration. So this is nothing but it is osmotic. And what you do, you again arrange and join with the some other pressure method to counterbalance it and check it. You try to increase the pressure such that what osmosis stop. The pressure at which osmosis stop, that is the osmotic pressure. Equilibrium is there. From that we can find the osmotic pressure. Understand this? This pressure, osmotic pressure, is denoted by pi. Is directly proportional to concentration. Okay? This pressure is a water pressure, and in terms of physics we have what? Gas pressure, P. So you put instead of pi P, if you apply gas law, okay? Ideal gas equation, then we have PV is equal to nRT. Therefore P is equal to N by VRT. N by V is nothing but this concentration. Concentration means what? Mole per liter. So here also we can write what? Pi is equal to N by V RT. RT related with P, then it is gas. But here related with this pi, that it is water constant. Instead of gas constant, water. And temperature is temperature. So it is nothing but it is water pressure. So in this way you can find osmotic pressure. Okay? By reversing, this is practical. Pressure applied to this container to stop osmosis. That is known as osmotic pressure. Okay, we can take one example related with that is 2.12. Okay, 2.12. In that we have to find the osmotic pressure. So we will try to find example number 2.12. What information is given in the sum, that we have to write on this side. What we have to find, that you write question mark, and then you decide which formula you have to use. Calculate the osmotic pressure. So first osmotic pressure you have to find, that is what it is question. Exerted by the solution by dissolving 1 gram of polymer. So here gram is given, weight is given, W is equal to 1 gram. Molecular weight is also given, is 185,000. The molecular mass is given. Is added in 450 ml of water. So water is given. So here V, that is 450 ml. If you convert into liter, then it is 0.450 liter divided by 1000. And temperature is given, is 37 degrees Celsius. You convert into Kelvin. Kelvin means 273 plus 37. How much? 7 and 3. So it is 0, 10, 1. So it is 310 Kelvin. Okay? 310. Now we want to find osmotic pressure. If this solution is given, then we want to find the osmotic pressure. Osmotic pressure pi, and this will come in what? Bar or Pascal. Barabar? So that will pi is equal to CRT. Pi is equal to N by VRT. N is nothing but moles. Mole is equal to weight upon molecular weight. So weight upon molecular weight into volume, R and T. Here another thing is not here, that is R. So we will write R. 0.08314. Oh, that is constant. So this we will put it here, W 1 gram, R means 0.08314 into temperature 310 into molecular mass. Here you can check it. 185,000. Its molecular mass is very, very high. That's why this substance is nothing but it is a polymer in the sum medicine. If it is 20, 30, 40, then you are not getting particularly clear. But it is here, molecular mass is very, very high. So from the molecular mass also you can estimate which type of compound it is. So it is nothing but it is polymer. polymer, I give the example nylon 6, polyvinyl chloride, PVC. Its molecular mass is higher. Okay? This into volume. Volume is 0.450 liter. If you calculate this, then answer is coming 0.000306. Well, this is coming. We convert into scientific notation. So it is 3.036 multiplied by 1, 2, 3, 4. That is 10 raised to minus 4. Okay, so osmotic pressure, here you compare. Answer which is coming. This pressure is very, very less. The water pressure which is created in the system. Okay, or this solution when it joined with simple water solution, then migration of water in this solution by semi-permeable membrane, that pressure will be very, very less. Okay, 10 raised to minus. You compare only power, 10 raised to minus 4, and you compare with the atmospheric vapor pressure. Okay, 1 bar, 760 mm. So this pressure is very, very. Again, if you try to increase the concentration increases. W by M, if you increases, then this answer will increase. So if more concentration, then osmotic pressure will be. Okay. Now we discuss want of factor. Okay, want of factor. In this chapter, we have discussed about the molecular mass of unknown solute. Okay, 4 methods are there. Molecular mass can be found with the help of first one is relative decrease in vapor pressure. Relative decrease in vapor pressure, T0 minus P upon P0 is directly proportional to the mole fraction of solute added. So N, solute added, I am writing small n for solute, N plus N. So this is relative decrease in vapor pressure. Second, molecular mass of unknown solution. Second is
P1 minus.
Same, that is P1, P2, it is same. P0 means solvent and P is solution. Second is relative decrease in vapor pressure. Relative decrease in vapor pressure means delta T is equal to Kf into molarity. F I have written means what? Freezing constant. So it is relative decrease in freezing point. Similarly, third, delta T is equal to Kb into molarity. Kb means elevation in position. Similarly, number 4, just now we have discussed, that is pi. Pi is equal to WRT by MV. Remember. So pressure, temperature, this all it is related with molality. Molality is related with the molecules. So it is all this property is the colligative property. In this we can find the weight upon molecular. So molecular mass you can find. But in this all solution, if you prepare the solution, the dilute. If you prepare dilute solution, then salt which is added, suppose I added NaCl, then it will separate. Na plus ion plus Cl. So in very dilute condition, dissociation takes place of the salt. If you prepare concentrate solution, then it will form what? One NaCl will link with another NaCl. Association will take place. So at higher concentration, association will take place, and at lower concentration, dissociation. Okay? Ions are separated. Similarly, polymer also. If you add organic solvent, then that organic solvent, if you add polymer, then polymer association and dissociation will take place. So whatever molecular mass you will find here by this method will not come correct. Okay, so another factor we have to add in this equation, that is what? Want of factor, scientists want of, that is I. I is equal to real molecular mass or molecular weight upon abnormal molecular mass or molecular
Wait.
real molecular weight upon abnormal means what association method. That will give quantum factor.
I.
That I you have to put it here in all equations. In all equations you have to write I. That is a correction factor. That factor, this divided by this, that will give I. That you put it here, then you will get what? Correct molecular weight of a compound, of a substance or of a solute. So this one-top factor is nothing but is real molecular weight upon abnormal. We take the example. Suppose that example is of benzoic acid. Next example, and which benzoic acid structure is like this? Ring say and COOH. If you calculate C6H5COOH, its molecular mass, if you calculate then approximate is coming 122. So real molecular weight is 122. But you find with the help of this osmotic pressure method or by any of this method. Practically suppose it is coming double of. So it is what? 244 m. Then quantum factor I is equal to 2. Okay, this 244 it is coming above. Means what association is taking place. Yes, if it is less then dissociation. And value will be what? Less than 1. So this factor you have to consider. So try to solve example which is given in your book. And that is related with the percentage association. Percentage association and percentage dissociation. I explain in short within 1 or 2 minutes why this factor is calculated in percentage. Okay, example number 2.12 of your book. In that same thing is given benzoic acid is added in benzene. Benzene means organic solvent is added. Benzoic acid is somewhat ionic character. COOH group. So this is ionic, this is organic, non-ionic. So this part, because of this, association or dissociation will take place. Here it is given. Okay, then the source depression in freezing point is this. What percentage association is there? This we have added in benzene. Okay, then dissociation will take place. Dissociation means take place means what? It will break from it. So here we have find the molecular mass as given in the sum. Molar freezing constant that we find with the help of this formula. From this formula you find what? Molecular weight of an organic which is coming 244. Here I am 244 R. So that will give R is equal to 2. Now degree of dissociation or association is given. X represent degree of association. Benzene may add here, then it is association. If you add in water, then dissociation. Organic में add करोगे तो साथ हो जाएगा, और inorganic solvent में add करोगे तो dissociation. Here degree of association is given. So suppose we take that degree of dissociation is equal to x. So suppose we have one number. Instead of 1 you can take in percentage 100 also. So it is 1 minus x or 100 minus x. Degree is counting. Okay. Next, this is x is what? Association takes place. So remaining molecules is this much. But we have to count of how many associate molecules is also there. So this is 100 minus x or 1 minus x. This is the remaining after association. But after association, other molecules are also there which are associated. So plus x. 100 minus x plus x squared. Remember these two factors. This is remaining after association, but after association, this you have to add it. This is associate particle. It is half. Why? Because dying by 2. X by 2. Two molecules unite and then associate. So x by 2 factor is associated. This is directly proportional to one-top factor I, which is given. This is directly proportional to one-top factor I, or which is equal to real molecular weight upon abnormal. Okay? So this thing given, you can find the I, or from these also you can find the I. Okay? So this is sum related with this. XSS sum also you have to find. This here it is applied to osmotic pressure. This you apply in any of the equation. Okay. Relative lowering vapor pressure means gas. Kf means freezing constant. Okay, molar freezing constant. Kb means molar elevation constant. Okay, increase in boiling point elevation. So here there is increase in boiling point. Here decrease in boiling point. And you can find with the help of the osmotic test. Okay. So thank you.
Thank you.